Alright, so we just went through the atmospheric layers. Let me pause this. We went through it really quickly because there really isn't a lot in the atmospheric layers, but weather does have a lot, so make sure you write down as much as you can and you watch the video as often as you can. Alright, so how much faith do you have in the weatherman or weatherwoman's predictions? A lot of times we make fun of a meteorologist because they end up being wrong in their predictions, but after you learn about what really goes into it, you'll see that it's impossible to really predict the weather. The fact that they have an accuracy within about 3 days is pretty awesome. All right, so let's first define weather. It's the daily condition of the atmosphere. Specifically, they're looking at the heat energy, the air pressure, the wind speed, and humidity level or moisture. Okay, so the sun's energy comes, or the heat energy comes from the sun and enters the atmosphere. Um, some of it is absorbed and some is reflected. You need to know that, and I'm circling it down here, that 51% of it is absorbed by the land and the oceans, and that 20% of it is reflected by the clouds because they're white. The ice caps also reflect back some of the heat energy because of their color as well. Okay, the 3 types of heat transfer. So once the heat comes in, it has 3 different options of what it can do. Conduction is when you have to have something touching another thing to transfer the heat. Your bare feet outside on the concrete, you would feel like that burning, the transfer of the heat. So it has to directly touch. Convection is when fluids, that can be gas or liquid, the heated up fluid is rising to the top and the cooler is falling to the bottom. And this is exactly what causes weather. So whenever we talk about weather, we're mostly considering convection. An everyday example would be your upstairs being hotter than your downstairs all throughout the year, except for maybe the room over the garage, because in the winter there's no heat to rise up unless you're heating your garage. Radiation is through empty space. This is the way that we get the heat from the sun. It also, if you sit by a fire, you don't have to touch the fire. You don't have to be above the fire to feel the heat. It radiates outward, so that's another example. Okay, the greenhouse effect is caused by increased levels of CO2. The Earth has done this all by itself many times. We've had global warming many times. As volcanoes they erupt, they release lots of CO2 and it builds up in the atmosphere. It's also true that burning fossil fuels adds to it, burning coal, gasoline, oil. And so they ask humans to do that as least as they can because we don't want to add to the Earth's normal greenhouse effect. We want to just let it have what it would normally do instead of making it worse. Okay, so since a lot of people don't believe global warming exists, I put this on here. Extraordinary claims need extraordinary evidence. So let's look at the evidence. So in 1982, the scientist that's being hidden up here, there he is, started taking pictures of the North Pole, and they started to notice some trends. Okay, so this is in 1982. The cooler regions of the water and the air are going to be in the blue, and then warmer is going to be in the orange and the red. 1986, try to remember that the Earth also strives for an equilibrium. If we have a really cold year, it's followed typically by a really warm year, and it tries to, equalize itself. 1988, 90, 92, 94, you can see it's getting a lot warmer. 96, 98, 2000, and 2002, 2003. This is huge proof of global warming. And so why should we even care about that? So these little animals that are in the pictures here, these little bacterial animals, are really small. If they die, then these animals die because that's their food. And eventually it trickles up to humans, and I will show you this video in class of an Eskimo talking about how the seals don't come there anymore, and Some of the bigger fish don't come anymore because the water's too warm. Okay, air pressure, it says the measure of the force of air pressing down. Remember I said that we are at the bottom of the ocean of air, and so it's highest at sea level. We have all the weight of the atmosphere on our shoulders. Gravity is what pulls it down, and it does change a little bit based on what's going on with the air. Okay, so what affects air pressure? There are three things. Temperature. It says density goes down or decreases when it's heated, and that's because the molecules will spread out. You don't have as many particles or as many molecules in one area. Water vapor, moist air, is less dense, and that's because the hydrogen and the oxygen would have been separate pieces, and now they join together, taking up less room. Elevation, as you go up in the mountains, air pressure goes down. This is why humans can't live at the top of Mount Everest. The pressure gets so low that we can't breathe. Okay, so mark an area for tools. We're going to go over probably about 5 tools that you need to know, and this is just the first of one of them. So a barometer measures air pressure, and it shows you 2 types. The mercury barometer measures it in inches of mercury, and the aneroid measures it in millibars. Okay, high pressure says the air mass cools, the air shrinks, more air moves in, and because there's more air moving in, it's high pressure. It spins clockwise and outward. You need to write both of those, clockwise and outward. This is usually a sunny, cloudless day. This is what it causes or brings about. Low pressure, the air gets warm and spreads out, so we have less pressure. And then it spins counterclockwise and inward. It pulls in like a vacuum. Typical low pressure areas would be, cooler days. It gets windy. And this is because the air always rushes from high to low pressure, so it's rushing into the low pressure. And so it brings about clouds. It also is what causes hurricanes and tornadoes. And think of those things. They suck everything into them because they're low pressure. Everything moves from high to low pressure. Okay, so we have land breeze and a sea breeze. Winds are always named by the direction they come, so a land breeze comes from the land and a sea breeze comes from the sea. What you really need to know here, though, is this diagram. And you want to make sure, you see this whole convection current here, you want to make sure that you're reading it from the bottom. So this one is a sea breeze, it's coming from the sea. And a land breeze is here, it's coming from the land, and you need to know which one happens in the afternoon and which one happens at night. All right, more tools. Wind speed is measured with an anemometer, and it's measured in knots, K-N-O-T-S. Wind direction is measured with a weather vane, and we already said that they're named by the direction they come. So a nor'easter comes from the north and the east. We just had one, and we have them a lot in the winter. When they come from the north, they bring colder weather with them, and they're coming off the water from the east, so they bring lots of snow or lots of rain. Okay, moisture in the air, we call it humidity. And warm air can hold more water than cold air. But every single air mass has some type of a dew point, a point where if it reaches that temperature, that gas vapor is going to turn into liquid water, and then it's going to rain. So that's what the dew point is. Relative humidity, relative always means compared to. So your sibling is the sibling compared to you, but the child compared to your mom. And so when we say your relatives, that's what it means. So when we talk about relative humidity, we're saying how much humidity is in the air compared to how much it can hold. If it reaches 100%, it's going to rain. Okay, a rain gauge measures how much rain has fallen in inches. A hygrometer or a psychrometer, both of them measure relative humidity. We're going to do these in class, so you're going to skip this. You don't have to write these down. Okay, the jet stream, we talked about it a little bit, so you can see it in the picture here. There's a polar jet stream and a subtropical jet stream, and they travel from the west to the east, and this is a meteorologist's worst nightmare because they could have everything set up and it's going to be a nice sunny day, but then the jet stream comes in and brings, if it dips down like this one right here is dipping down right here, then it's going to bring colder temperatures. If it's coming up, then it's going to bring warmer temperatures than normal. Oops, I'm going backwards. Okay, an air mass is an area of air miles wide that has relatively the same temperature and humidity. We have two types. Maritime means it's over the water, so it's going to bring lots of moisture and rain. Continental is coming off the land and it's going to be dry. And it can either be polar, which is cold, and tropical, which is warm. So it's either coming from the equator or coming from the poles. So it says, how would you describe a maritime tropical air mass? You would describe it as wet, rainy, and warm. These are the air masses that affect the United States. And you can see right in this area, we have 3 different ones affecting it. And so this is where we get our tornado alley. Too many air masses spinning in different directions with different temperatures, and we get tornadoes. Okay, we're going to go over these fronts, what the symbols look like whenever you come to class. And we will do this quiz also in class. So you're actually done. See you on Tuesday.